You have description, explanation, international system of units, accuracy, and precision. Again, I'm not going to read through the definitions for those. You can pause this and read through them yourself. Description and explanation. Descriptions and explanations can lead to the interpretation of your observations, which can lead to hypothesis formation. That's what we spent the first lesson talking about, was hypothesis, right? So these things are going to help you form your hypothesis. The International System of Units is used to make measurements clear around the globe. We talked about that very, very briefly at the end of the last PowerPoint. The reason we use the International System of Units is so that everybody can use that, and we can all have the same kinds of measurements instead of a foot being different here than a foot is, say, in India or something like that. All SI units are derived from 7 base units. SI is another name for the International System of Units. A prefix is added to the base unit to indicate whether or either a fraction or a multiple of that base unit. So you add a prefix to either make it bigger or smaller. Prefixes are based on powers of 10. That's why the SI system is so easy, because you're just adding zeros. Here are base units. We have length, mass, time, electric current, thermodynamic temperature, amount of substance, and luminous intensity. You're not going to really have to worry about these guys down here. You probably know what a meter, a gram, I'm not sure. I don't really like that they did kilogram. That's not a base to me. And second are. Don't worry about an ampere, Kelvin, mole, and candela. Alright, so here are suffixes. Or, excuse me, our prefixes. Going up. So, if we make them bigger, so to make more off of the base, we have deca, hecto, and kilo. Right? You've definitely probably seen a kilometer or a kilometer. If you know anything about computers, mega, giga, and terabytes, those are all units of storage for computers. If we go down, we have deci, centi, milli, and I think you guys have probably seen those before. Below that we have even micro and nano, so these are still really small things. Again, the idea here is to remember that we add to the base, so this right here is our base right here, our 1 is our base. And then to make it bigger, so to make more, we have deca, hecto, and kilo. If we want to make it smaller, we have deca, centa, and milla. So it takes 10 decimeters to make a meter, 100 centimeters to make a meter. And then it goes the other way up here. It takes 10 meters to make a decameter, and 1,000 meters to make a kilometer. Accuracy and precision. These were both part of your vocab. So, accuracy is grouping. Accuracy is hitting where you want to hit. So here we have high accuracy, right? We're all around the bullseye. Precision is that grouping. Right here we have high precision. Everything is grouped together. We are in the same spot over and over and over. Here we have neither. Low accuracy, low precision, and here we have high accuracy, high precision. So one last time, accuracy is hitting the target, precision is grouping. If you don't have either, you're just all over the place. If you have both, you're going to have a lot of shots right in the middle of the target. This is useful for when we're testing data. If it's not accurate, then we probably shouldn't use it. If it's not precise, then maybe something's going wrong with our testing that we're not getting the same results. All measurements have some uncertainty. No matter how well you do them, there's always some uncertainty. Maybe here we go. The quality of the tool will have an effect on how certain the results are. It's not always the tool either. Maybe you're doing a bad job of cleaning your containers out. So that's going to affect how much of something that you have. You have more in your container, so you have less to test. Scientific tools include journals, triple beam balance, thermometers, glassware, microscopes, computers, dissecting tools. There are a lot of tools that scientists use, and depending on what kind of science you're doing, it might be a different kind of tool. That will do it for this slideshow.